Hello, I'm Bo Kyung-lee from Dongguk University DTM Lab. The paper I will review is Product Innovation Information using Large Language Model based on TRIZ and patent mining focusing on sustainability. First, this is bibliography information for the paper. This study proposed a novel framework that integrates TRIZ technique with LLM to enhance product innovation process, focusing on energy efficiency and sustainability. The contents are the same as the structure of the paper. First is introduction. People claim legal right to invention by disclosing invention details through patent. As the number of publicly available patents continues to increase worldwide, patent exploration and solution discovery have become important challenges. TRIZ transform specific problem into generalized problem and provide solution direction based on 40 inventive principles. However, existing TRIZ-based systems rely on keyword and title-based search, limiting their ability to capture semantic relationship within patent data. LLM introduce deep semantic understanding and contextual reasoning to address this limitation, but they still suffer from hallucination issue. To address this problem, this study apply lag and limit the model to domain-specific patent dataset. This study aims to integrate LLM and TRIZ principle to provide sustainable patent-related innovation solution. Next is related work. First, TRIZ. TRIZ is regarded as a systemic knowledge-based approach for creative problem-solving. Recent study applied TRIZ principle to analyze how multimodal AI systems resolve inherent contradictions that arise when integrating and reasoning over different data modality. In addition, TRIZ has three core concepts: pattern of system evolution, ideality, and contradiction, and its TRIZ problem-solving process generally applied at least one of these concepts. First, pattern of system evolution refers to the regularity that systems follow throughout their life cycle, which are important for predicting future system evolution. Next, ideality is one of the aims of TRIZ, and increasing ideality is important. The ideal final result helps indicate the direction and future improvement of a system. Finally, contradiction is classified into two types: physical contradiction and technical contradiction. In addition, the contradiction matrix map design conflict to inventive principle and align well with data-driven system in that it enables direct parameter-based reasoning. Therefore, this study selects the contradiction matrix as the TRIZ tool. A language model learns probability distribution of words and token sequence and is trained on large-scale text data to capture pattern and regularity in forming meaningful sentence and document. LLM refers to transformer-based language model containing hundreds of billion or more parameters. LLM performance is evaluated using various metrics. Recently, traditional automatic evaluation metrics, as well as human or LLM-based evaluations of coherence, factuality, safety, and task success have been used together. RAG is a technique that improves LLM performance using knowledge from external database. It generates response by combining pre-trained LLM knowledge with information retrieval from external documents and knowledge base, and was introduced to mitigate hallucination issue and improve the accuracy and reliability of output in knowledge-intensive tasks. In addition, Llama 2-based RAG systems show higher accuracy than general fine-tuned model. The leg framework consists of the following three main components. Design indicators are criteria for evaluating the importance of quality of patent derived from patent data analysis, such as patent citation and patent family size. In addition, sustainable design indicators serve as the foundation of sustainable design criteria and include environment, economic, and social aspects. In this study, LDA topic modeling was applied to relevant literature to derive sustainability and energy efficiency related indicator for energy efficient design recommendation. The derived indicators were later used as criteria for Llama 2 to summarize patent and assess energy efficiency related information. The energy efficiency design indicators selected in this study are presented in Table 2. Next is methodology. This study proposed solution to innovation problem using LLM and the TRIZ principle contradiction matrix. The system recommends patent relevant to usual problem based on USPTO patent data. Figure 3 shows the system architecture of the proposed framework, and Figure 4 presents the end-to-end workflow of the system and sequentially shows the overall execution process. First is the data selection. In this study, a total of 3,720 recent Samsung patents were collected, and Samsung and some random patents were used as the research target. Next, in the data pre-processing, patent information such as patent number, abstract, detailed description, and claim was extracted by analyzing XML file and stored as CSV file. Next is the patent summarization. In this step, Llama 2 7-bit chat was used to extract the core content of patent. Patent abstract and claim were separately summarized and evaluated. Abstract summarization provides an overview of the entire patent, and claim summarization explains the inventor's right and the commercial value of the patent. In addition, the summarization focused on the following three key aspects. Figure 5 shows the overall patent summarization process of knowledge base creation. Next is the embedding and vector database. In this step, the patent knowledge base were converted into vector representation to retrieve information related to specific problems. Three embedding models were compared, and BGERG model was selected considering retrieval performance and space efficiency. The generated embedding were then stored in the Chromat vector database, where each patent entry was indexed as a single document. Next is the TRIZ 40 principle integration. TRIZ consists of 40 inventive principles, and in this study, LLM were used to recognize and classify technologies based on TRIZ principle and extract the principle applied to each patent. In addition, for efficient integration, 40 TRIZ principle and example were embedding and used for lag-based retrieval. This provides relevant TRIZ principle along with its patent summary and support user in patent selection and decision making. Figure 6 shows the TRIZ principle embedding and integration process. Next is finding and discussion. First, in the claim generation experiment, the text generation capability of Llama 2 was evaluated. Claims were generated based on the abstract of the bicycle wheel drive apparatus patent, and compared with the result of other models as shown in Table 4. As a result, Llama 2 shows superior performance in patent claim generation based on patent abstract compared to other model, indicating that Llama 2 can generate patent claim despite the formal and technical language used in patents. Next is the construction, extraction, and summarization experiment. In this study, an experiment was conducted to evaluate Llama 2 contextual understanding and information extraction capability. A contradiction extraction experiment was conducted on the HVAC controller improvement patent, and Llama 2 identified technical improvement factor and contradiction factor at the same time. As shown in figure 7, the contradiction between comfort level control and device complexity from previous HVAC study as also identified in the Llama 2 output, along with additional contradiction relationships. Through this, it was confirmed that Llama 2 can effectively identify and extract contradictory parameters for patent document. Next is the patent retrieval quality evaluation experiment. In this study, the patent retrieval quality of the Llama 2 base lag system was evaluated. Previous research conducts patent retrieval related to biodegradable packaging using keyword-based retrieval, but irrelevant patents were also included as shown in figure 8. In this study, a knowledge base was constructed by combining the top 20 patents from the previous case study with 2036 random patents. After that, the input prompted biodegradable packaging was used to retrieve relevant patents. As a result, as shown in figure 9, the system successfully retrieved 5 patents related to biodegradable packaging without including irrelevant patents. Therefore, it was confirmed that the lag-based system produced more highly relevant patents than the previous keyword-based system. In addition, Table 5 compared the patent retrieval approach of the two systems. Next is the case study. In this study, a case study on mobile device was conducted to explore solutions for improving energy efficiency, and Samsung patents were summarized and stored in the Vector database as the knowledge base. The user aims to design an energy efficient touchscreen display while maintaining the device size and provide user requirements together with contradiction matrix parameters. After that, the system suggests relevant TRIZ principle as shown in figure 10, and retrieved and recommend relevant patent using LLM and lag as shown in table 6. In addition, figure 11 provides the TRIZ principle applied to the recommend patent along with patent summary information. Finally, as shown in figure 12, the patent titled display device, including a touch line connected to a touch electrode overlapping a power supply line, was suggested as a potential solution, demonstrating a display structure that reduces power consumption and the potential to improve energy efficiency. Next is the conclusion and future work. This study proposed a Llama 2 and lag-based patent recommendation system for energy efficient and sustainable product innovation. Experiment and case study confirmed its applicability in patent retrieval, information extraction, and claim generation. Future work includes comparison with various LLM, integration of additional patent database, and further validation through diverse use cases.